Hi everyone. So we're going over Labflow. Labflow is where we go on to do all our labs for chemistry. They're virtual labs. Once you log in, you're going to get a screen. It's going to look something like this. Some labs you'll be able to start right away. Some you have to wait until the week that they open up. So we're going to be doing the first lab, separating components of a mixture. Now, sometimes it's hard to tell with the labs like how to move them, but right here, this is where you have the little move bar. Okay, it's really hard to see. They actually updated it because before it was a very thin line. But you have this little bar where you can move between things. So this first one, whenever you see PDF, so you'll see PDF on all of these. Okay, that's kind of like your lab book where all that pertinent information is at. So you always want to have that one open, okay? Because you're going to reference it for all of your information. Then it provides you with small videos to watch on how to do important things that may or may not be on your guys' pre-lab quiz. So these videos are short to watch. Okay, you could take some notes on them, and then yeah, use them as you will. Especially if you're going to go to another chemistry course or biology course, you need to know these skills. As you move forward, you're going to have a pre-lab quiz. Okay, so you're going to open it up. It's going to say, do you want to attempt the quiz? You have two tries on these quizzes. So two attempts per quiz, and it always takes the highest grade. Right? So always attempt to get that higher score. Next is your actual report that you have to write. Okay, so click on the report. No user play. We don't want that. We want report. Sorry, mine looks different from yours. Okay, so we have our report. And in this one, it says, how am I going to collect my data? I am going to collect it virtually. We're not in person, we're virtual. So next. Now that I've done that, it says, use the image provided below to collect data virtually. If you have technical issues with the virtual data, please contact support. Now, on everyone's scale, you're going to have different numbers. So make sure that your numbers correspond to your entry. It says report your measurements to the correct number of significant figures. So procedure, clean and dry two evaporating dishes. Label them one and two. Okay, so this right here on the top is an evaporating dish. Record the mass of the evaporating dish number one to the nearest 0.001 grams on the report sheet. All right. Now, one of the common mistakes I see is everybody likes to go up here and go, oh, okay, so I need to report this number. And they write that, and then their entire report is wrong. Um, so that's not what it's asking you. It wants you to report this number here to this many places. So let's go to our report. Okay. On our report here, it talks to you guys about the difference of physical properties and chemical properties. What's a homogeneous mixture or a heterogeneous mixture? And we went over those in our PowerPoint. Then it talks about techniques. So decantation and filtration. So to decant something as opposed to filtrate something. Decant just means you're separating it, right? Gently pouring something out of the container, but you're not filtering it. When you filter something, you're actually capturing any of the small particles that may be inside of that liquid. Okay? So filtration is actually a better technique than just decantation. Decantation doesn't always capture all the solids. So you have extractions, you have sublimations, so they're all different little process in what we do to basically extract our compounds, right? Separate them. How do you do your math? So in this one, we want to calculate percent composition and percent recovery. The equations that we're using listed right here. So the percent of your component is equal to the mass of the component divided by the mass of the sample in grams. You multiply it by 100, and that gives you a percentage. So the example here is, what is the percentage of silicon oxide in 2.56 grams of the sample mixture if 1.25 grams was recovered? So you take the amount that you recovered, how much did you actually get, versus how much was inside the total mixture, right? The part over the whole. So that's the way I like to explain these kind of percent compositions, type of questions. Is you want the part over the whole times 100. So make sure you reference this for your equations. Okay? All right, here is the part that we are in for our actual lab now. It says clean and dry the two evaporating dishes. Done. Record the mass of your evaporating dish to the nearest 0.001 grams on the report sheet. Okay? Obtain from your instructor a sample of the unknown mixture. Write that unknown number on your report sheet. Now, the number that you're going to get is actually going to be provided to you in this lab after you put in your entry. So when I put my entry in, 39.595, see, I'm labeling it to the nearest, I forgot what this is called. I don't know. I think it's 10th of a thousand or something. I'm not sure. So three after the decimal. Three after the decimal. Now that that's reported, it says the same thing. You notice that it said here on the lab. It's going to say it here. What is our unknown number? You have been assigned the unknown number 4. So all you do is enter the number 4. Right? And you're going to continue through this where it's going to ask you, okay, calculate the mass, give it to me in this many significant figures, right? Now, one thing you might want to do is on your note sheet, right? So here I'm going to go assignment number 2, and this one I'm going to call it lab 1, separating mixtures. So this is going to start my new assignment, number 2, right? You always want to write down your information. Now, something I didn't do on this one, but I want you guys to do it because you guys are learning this, is write down the techniques on that video. What's decantation? What are all of those things? So write all your vocab words, write down vocabulary words. I'm like, oh, that looked weird. So write down your vocabulary words, right? So those are the words that we were seeing up here, especially if you don't know what they are. And after you're done writing those vocabulary words, write down your equations because you're going to be using them. So if you don't remember what heterogeneous is or homogeneous, write those words down, right? So, like I said, they were defined inside our PowerPoint. So I want you guys to go ahead and define these yourself. What are components? Right? You want to know the differences in physical properties. What are physical properties? Okay. What's the physical properties of copper? Do we recall? It has a very unique color, right? It's hard. You could turn it into different things and it's still copper. So separation techniques here. So the different types of separation techniques. So what do we have? We have decantation. What's decantation, right? The process of separating a solid from a liquid by gently pouring the liquid out. So abbreviate. You don't have to write everything down if you know you're going to remember. So gently pouring liquid out. Gently pouring the liquid out of the container. Then there's the next one, filtration. Okay. So this one is the means of using a filter paper to catch solids. So solid particles. Look at that. We got some more. We got the word extraction. So we read extraction right down here. This is the separation of a substance from a mixture by preferentially dissolving that substance in a suitable solvent. By this process, a soluble compound is usually separated from an insoluble compound. All right, so you're going to extract something. So, and here's the thing, do you guys know what soluble and non soluble are? Right? If we don't know what those are, then guess what we should do? We should define them. So soluble means something that dissolves in water, and non-soluble means it's not going to dissolve. Okay, or not just water, but whatever component it might be in. So we know that polar dissolves with polar and non-polar dissolves with non-polar. And you mix two things together, right? They're not going to mix well. So for example, like I said, actually let's write it down. Polar dissolves polar. And you're like, what in the world is she talking about? Okay, well, you have something like water is a polar molecule, right? And water dissolves practically anything. So if something else is polar, it's going to dissolve in water. So water and let's see, hmm, water and salt dissolve. Okay? They dissolve together. Things that are non-polar, polar dissolves polar, non-polar dissolves, guess what? Non-polar. So gasoline and let's say, what else can we do? Gasoline and oil, they dissolve each other. Okay? So those are two things that we kind of know that are non-polar. Um, non-polar and then the ones we know that are polar. If we were to mix water and oil, guess what happens? They don't mix. They're non-soluble. So in other words, this is non-soluble. And we could actually distract the oil from the water. Okay? We have sublimation. Basically, sublimation, you're going to take your solid and turn it into a gaseous state, right? And therefore, you're separating that compounds from each other, and then you collect your gas. Okay? This is a common process for like sodium chloride or things like that. Okay? Write it down, right? Sublimation, turning your solid into a gas. Okay. Going into the next part, we want to learn how to calculate our percent compositions. So make a little section and it's going to be called calculations. All right. So calculating percent composition or your percent recovery of a substance. Let's write our equation down. So the percent of a component, right, is equal to the mass of your component divided by the mass of the sample in grams. And grams is a unit that we use to measure the mass of something, right? So this is a math problem, and I like to put my little math problems inside of parentheses and makes it neater. And when it makes something neater, it's easier to see. Multiply it by 100 and boom, all of a sudden it's a percentage, right? A lot of us don't like working with percentages. All it is a number over 100, right? It's a number that you multiplied by 100. So, um, okay, like I said, this can easily be translated as the part divided by the whole times 100. Okay? What part do you have, and so how much do you have, and what's the total amount of it? That's what kind of what you want to see. How much you have, and what's the total of it? Right. The next equation that you have, this is number two, lab one, separating mixtures. And you know what? Sometimes someone, you want to put down this 2B, 2A on this one to help you get more organized. You can do that as well. And if you guys have better techniques, like some of you guys were probably an avid in high school, um, I don't know what kind of AP Chem or whatever you might have been in. Well, actually, if you were in AP Chem, you shouldn't be in this class. You should probably be in like Chem 24 or something. Okay. So the next equation is percent recovery. Okay. How much did you recover of your substance? So one more time, it's the total, right, of all your stuff that you recovered divided by the amount that you used. In this case, the grams of your mixture. So this is total recovered and grams of mixture used times 100. All right, that's the best recovered. All right, my spelling is off today. I think recovered. All right, embarrassing. Oh, okay, so total recovered divided by the grams of your mixture used. So you want to add everything together. So in the example they have your grams of sodium chloride plus your grams of ammonium chloride plus your grams of silicone dioxide. So all of these were added together and they were divided by the grams of the mixture. And then they multiplied that by 100. So if you ever get confused on what an equation is, don't just write it down. Break it down. What does it actually mean? Total recover divided by the amount that you used, right? Feel free to go over the little chart here, this illustration on how drying in something, what do you have left? There's actually questions on your lab at the end of it that's going to be related to this, right? Um, if something is still wet, what might you have gotten? If something dried, what did you get instead? Those kind of things. So reference this page right here. It's going to help you. MX5. Okay, so that's a reference page. Remember that when you get to that question, and it's like, oh, this way ended up weighing more. What could have happened, right? Or it ended up weighing less. All right, so this one is going to go through your little process right here where you're going to start heating up your mixture. And this is actually in a nice little video on how to do that. It's going to be right here. You've seen a crucible. So how do you use a crucible? What are we doing? Basically, we're drying out our mixture. So we're drying out our mixture. All right. It wants you to record everything. Make sure you record your notes on your lab, right? So when it's time to start recording your notes, oh, that's a page. Put it on the back, right? So this could be like your notes for your lab. Um, so I like to take my notes in pencil because they're scratch notes. So or scratch notes, right? So like, how much did you record? Those kind of things. Like, what did you write down? I'm not going to reset my attempt. I'm going to keep it. So in this one, I know I have two crucibles. I have crucible number one and I have crucible number two. Okay. I know that in one of them, I have 39.595 grams. Okay. And I have an unknown number four. So I'm just taking some notes and writing my stuff down. That's all I'm doing. So I have notes for lab. I have unknown number four, crucible one, and crucible two, right? As I continue, it says mass of the evaporating dish number one and the original sample. So here is my sample that I used. So this is how much the evaporating dish weighs. This is mass of the evaporating dish. And this is mass of the evaporating dish plus sample. And that is 40.433 grams. Right? And it wants me to record that mass of evaporating dish and sample. Right? And now it gives me a different procedure. So it says in the fume hood, place the evaporating dish containing the mixture on a clay triangle. So we know we're going to be evaporating it. right? Heat the evaporating dish with a Bunsen burner until white fumes no longer form. Ooh, so we're getting white fumes. Heat carefully to avoid spattering. Occasionally gently shake the evaporated dish using a crucible tongue, right? So we're moving it around. Spattering means just that it's going to be, it's so hot that the compounds are going to be jumping out at you, right? And you don't want that to touch you. It's going to burn. Okay. Allow the evaporating dish to cool until it reaches room temperature. Weigh the evaporating dish, the contained solid. The loss in mass represents the amount of sodium chloride in the mixture. All right, yes. So when we're looking at our dish, we could see that after subliming it, right, our mass has changed. So our mass is now a 40.319. We can see that we lost some mass here, right? So this is the mass after sublimation. So after sublimation. Okay. Now, do we really have 40.319 grams of a substance? Right? What do we need to remove in order to find out how much we actually have? Right? We need to remove the mass of the evaporating dish. All right, here it's having you do the same thing. Now you're going to do it for evaporating dish number two. So you're going to write your stuff down, and then continue on. When you're going to do your math, always remember that the mass of the sample, and this is going to be, let's say, number one, right? Because we're going to work with this one. You have to remove. Let me actually use a color for you guys. So you're going to have to remove the mass of your evaporating dish from this. So you have 40.319 grams minus 39.595. Okay. Oh, excuse me. That's going to be the mass of your sample. Right? So that's going to be 4. That's what? 11 minus 9, 1 more, carry 2. 12 minus 5, 2 more, that's 7. What do we have here? 9 minus 9 is 0. So the mass of our sample is actually 0.724 grams. Okay. And then what is the mass of what we lost, right? How much got sublimated? So this is the sample and that was left over. And this is going to be the what got sublimated. Okay. All right. And then do your math with this one as well. And then if you want to know how much did you start with, so mass of sample number one you started with is going to be your 40.433 minus your 39.595. Okay. And that's going to be the mass that you started with. So started with this, whatever that's going to be. Sample left over was this, and the amount sublimated is going to be right there. So 3 different things that you were able to figure out. And remember, when I mean sublimated, that's the amount that the gas that left. Okay. Now, whether or not you're going to use that information, I don't know. Right? That's going to come later in the lab when you start answering those questions, like how much did you have? How much was sublimated? What did you lose? Right? All of those you were able to obtain just by doing those 3 simple equations using these numbers right here. go back to our lab right here. Okay. Oh, another thing. Let's say you don't want to write your notes inside of your notebook, right? Or you do want to write them in your notebook. You could always print this out, write everything out, and then staple it into your notebook. So that way you have like a journal of the process that you've gone through, right? So write everything out. It's a lot more organized if you just print this form out and then put it here. You will need to submit. Let me say that again. You will need to submit proof of your work. Right? So whether this is your work, you're going to take a picture and submit that, or if you're going to print this out and take a picture of your work and submit it. Make sure that your work has your name on it, that it's verifiable to be your work. Okay. Um, every lab that you do will ask you to submit proof of your work. So every lab that you do, make sure you keep a good copy of whatever it is that you're doing. Right? The equations are super simple, showing the percentage, percent recovery. So we already went through those ones. Right? You should have a breeze through this lab. Any questions, just shoot me an email and I'm going to be here to help you however I can. All right, you guys take care.